Hi, hi everyone. Welcome back to our course manufacturing process, part 2 of week 1. So the learning outcome is explain the principles associated with casting process and assess their process dynamics and performance. Today we are going to discuss about overview of casting technology, fundamentals of casting process, heating and pouring, and then solidification and cooling. So in general, we have seen many products in our day-to-day life which are made by casting process. For example, engine cylinder, compressor cylinders, pipe fittings, jewelry items. Many products like gearbox casings, traffic lights, these are made by a process called casting process. So our aim in today's session is to study how a product is made by casting, what are the dynamics, process dynamics involved in a casting process, etc. So in a casting process, a metal is heated. That metal will get converted into liquid, and that liquid is poured into a cavity. Then that cavity has a specific shape. When this molten metal cools down in that specific cavity, it will get changed to the shape of that cavity and we will get the final finished product. And the final finished product will have the shape of the cavity. This is the basic principle in a casting process. So starting work material is a liquid or in a highly plastic condition, metal in a highly plastic condition. And this metal is heated, we get molten metal, and molten metal after solidification, we get a product which is made by casting process. Normally we use metals, ceramics and polymers for casting process. So basically the process involved in a casting process is solidification process. And solidification process means casting. It can be casting of metals. Metal are casted. A molten metal is poured into a cavity, and this molten metal will have the shape of the cavity or the impression of the cavity, and then we get a final finished product from this. This is casting of metals. Glass working, we can produce glass by solidification process, and processing of polymers involves extrusion, injection molding, and other special processes. These things will be studied in our later sessions. Let us focus on casting of metals, how we can produce products by casting. There are two types, expendable mold casting and permanent mold casting. Expendable mold casting means once we produce a product, we have to destroy the mold. The mold is destroyed to take out the product. That is called expendable mold casting. Normally these molds are made by sand, and then permanent mold casting, the mold is made up of metals. That means we can reuse the mold again and again. Normally for mass production industries, we go for permanent mold casting process. So in general, we have two categories: expendable mold casting, normally sand casting, and then permanent mold casting, which are made up of metals. Casting is a process by which molten metal flows by gravity into a mold where the molten metal is solidified and which forms the shape of the cavity, mold cavity. The term casting also applies to the part made in the process. What are the processes involved in a casting? The main processes involved in a casting is, one, you have to melt the metal. So heat the metal and melt the metal. Number two, pour the molten metal into the cavity. And three, let the molten metal freeze. So these are the three processes involved in a casting process. So we melt the metal, molten metal is poured into a cavity having a desired shape, and this molten metal solidifies to produce the required shape. So these three processes are involved in a casting process. What are the advantages of casting? As I said, our day-to-day life, many items in your car, if you take engine cylinder, engine head, gearbox casing, compressor casing, impellers, many things, jewelries, many items can be produced by casting. So what are the advantages of it? Advantage is very complicated shapes or complex geometries can be casted. We can produce external, that means projections, and internal parts. So some casting processes have a net shape or near a net shape. We can get close accuracies, very good, or close shapes can be produced, and very large parts can be produced by a casting process. Now, in general, whenever we use the word casting, the first figure, the first name comes in our mind is sand casting, which is started in old age time, and still we are continuing this casting method, which is a sand casting process in which we use sand to produce a mold, and this mold is used for producing the castings. So in here you can see there are two types of molds we produce. One is open. You can see here we produce a shape by sand, and then molten metal is poured into the cavity and we get a final finished product. Normally metal billets can be casted, and these billets can be sent to different industries. This is open mold, which is a very simple form of casting. But when we come to closed mold, which consists of two part, upper part and lower part. Upper part is called cope, and lower part is called drag, which consists of a downsprue, which is basically a channel, a pouring cup, then downsprue is a channel, then a riser, which is a reservoir, and then through the channel, this is the cavity. This is the shape of the product we have to produce. So in a casting, what we do is, if we want to produce a pulley, then we have to make a pattern made up of wood or metal using metal or wood, and then this pattern can be used for making the castings. So if you see here, we need to produce a particular product having a particular shape like this. So first step, we have to produce a pattern having the same shape but oversized, because shrinkage of metal takes place, and this pattern is fixed in the flask, and the flask consists of cope and drag, and the pattern is surrounded by the sand. Sand, and it consists of a riser, a downsprue, etc. So what happens is, when we remove the pattern from the mold, what happens is we can produce a cavity which is having the desired shape of the product. So what we do, we melt the metal, we pour molten metal into the downsprue. The molten metal will pass through the downsprue, it reduces turbulence, etc. It is stored in a reservoir, and then this molten metal enters the cavity and it fills the cavity. And after solidification, we can remove all these parts and we will get the final shape exactly like this. This is the main process involved in a casting process. And the important parts in a sand casting processes are basically a pouring cup, a downsprue, then a riser, and then as I explained, a core. A core is used for producing holes in castings. Normally we use in expendable castings, we use sand or plaster. Now there are two categories of casting processes. First is expandable mold cast and the second is permanent mold cast. In expandable mold casting process, normally we use sand or plaster to make or to produce the mold. So the pattern, we produce a pattern made of wood or any other material, and then this pattern will be having a similar shape of the product to be produced, and also it is oversized. Why it is oversized is metal strings. Whenever we pour molten metal into a cavity, hence shrinkage allowance need to be given. So this pattern is surrounded by the sand or plaster, and then when we remove the pattern surrounded by the by the sand, when we remove the pattern, we get a cavity which is having the same shape of the product to be produced, and we pour molten metal into the cavity to produce a desired shape. In expandable mold casting, the pattern is surrounded by sand or plaster. So the main concept in expandable mold casting is we need to destroy the mold to take out the casting. That means for each product you need a separate mold. Normally this is sand casting or plaster castings. Permanent mold casting means we use the mold again and again. So the mold can be used over and over to produce many castings. Normally, these kind of castings are used in mass production industries, and the mold is made up of a metal. The advantage of permanent mold casting is very simple parts can be produced. This is can be taken as a disadvantage in the case of a permanent mold casting, but mass production is possible. This is the advantage of a permanent mold casting. In the case of expandable or sand casting, the advantage is complicated, intricate geometries can be produced by expandable mold casting. So whenever we have a mass production, we need to go for a permanent mold casting because we can use the mold over and over. Now, when we come to the expandable mold casting, the most common type is sand. The pattern is surrounded by sand. So we do the casting, or we produce a mold in a chamber. That chamber is called as flask. It consists of upper part called cope and lower part called drag. And mold halves, they contained in a chamber, we call it as a flask. They are separated by a line, we call it as parting line. As I said, we use a pattern in here surrounded by sand, and when we remove the pattern we get the cavity of the final finished product, and we have the pouring cup and then a downsprue. It is a channel. And the area of cross section reduces as molten metal is poured into the downsprue. Its speed increases and the turbulence, splash, etc. reduces, and it enters a riser where it is stored, and then then it enters the cavity, and the metal fills the cavity from the far end towards the beginning. So this is how we produce a casting using a mold in a sand casting process. So these are the main parts of a sand casting process. Again, pouring cup to reduce splash, and then downsprue, turbulence will be reduced, velocity increases, then it enters a riser to store. This is a reservoir, riser is a reservoir, and then we have the cavity to be filled. Whenever there is a requirement of a hole, a core is used. Core is also made of sand. This will produce a hole or internal part. So these are all about sand casting, and normally the pattern is oversized. Why it is oversized is molten metal is poured into the cavity. After some time, this metal shrinks. So reduction of volume takes place. Hence, normally whenever we produce a pattern, it will be oversized, accounting the shrinkage allowance. Now, what is the use of a core? I have already explained. A core is used for producing holes or internal parts. A gating system is used to minimize the splash and turbulence. Already we explained. A riser is a reservoir which stores molten metal. Then heating. Definitely we need molten metal. How to produce molten metal? Metal is heated to its melting point. So the solid converts to liquid after melting point. So molten metal is produced. So heat to rise till melting point. Then heat of fusion to convert solid to liquid at melting point, and raise from melting point to the pouring temperature. So three stages are there in heating process. Heat required to raise the temperature till melting point, heat required to change solid to liquid, heat of fusion, then from melting point, molten metal at melting point to pouring temperature. So heating takes place in three stages. Now, one of the important factor we have to study in a casting process is time required for solidification. TST. What is the time required for solidification? Time required for solidification is the time required for the casting to solidify after pouring. So the time required for the metal after pouring till it solidifies. This time we call it as solidification time, which is a very important design parameter in casting. So how it can be calculated? TST is equal to a raised to n. So V is the volume of the casting, A is the surface area of the casting, N is a constant exponent, which is a constant, normally N is equal to 2, and Cm is a mold constant, which depends on the material, the temperature properties, and the melting point. Using this, we can calculate total time required for solidification after pouring, which is equal to Cm times V over volume divided by area raised to N. N is normally 2. So a casting with a higher volume to surface ratio. So if you take here this ratio, whenever volume to area ratio is more, you need more time for solidification. When volume to area ratio is less, you need less time for cooling or solidification. This is the connection between solidification time and the volume to surface area ratio. So whenever we design a riser, which is a storage, we know that. Whenever we design a casting, the shape of the casting, so we need to account this time. The time required for solidification in the case of a riser must be more than the time required for a casting. Otherwise, what will happen? The riser will solidify before the casting. So the metal will not flow from the riser to the mold. So in order to avoid that, in order to avoid the choking of the flow, we have to make sure that the riser should have a more solidification time than the casting to be produced. This is very important in the case of a casting process. So TST for riser must be greater than the time for casting. Otherwise, the metal will solidify in the riser itself, and the metal will not flow or enter into the cavity, will not get a shape of the product to be produced. So this is very important. So volume by which parameter dictates this TST is volume to area ratio. So we need to design riser in such a way that volume to area ratio is much higher than the casting to be produced. So these are the things. So whenever we take a casting, we have to account the solidification elements, the shrinkage elements, all these things need to be accounted whenever we design a casting process. Value of Cm for a given casting operation can be taken from the experimental data and we can use it. Now let us see an example in here. We need to produce a product here by casting rectangular plate. The size of the rectangular plate is 7.5 centimeter by 12.5 centimeter by 2 centimeter. 7.5, 12.5 is this is the shape we need to produce. It's a rectangular plate. Solidification time is for the casting is 1.6 minutes, and the solidification time for the riser, which is the reservoir, which is 2 minutes. So look at that. Casting time 1.6 minutes, and for the riser 2 minutes. The time required for riser is always greater than the time required for casting. We need to design a riser in such a way that its time for solidification is 2 minutes and casting will solidify in 1.6 minutes. So that means we need to design a cylindrical riser. The shape is a cylindrical riser as it is given in the question. Its a diameter d divided by h. Diameter to height ratio is 1. We have to find what is the diameter and height. That is the design. And the condition is time required for the riser to solidify is 2 minutes, which is more than the casting, which has only 1.6 minutes. And the product to be produced is a rectangular plate. As I explained before, we have to use our equation for Chevronn's equation, which is Chevronn's equation. I already explained to you. Chevronn's equation is TSTCM times V over A raised to N. From here, we get this is the equation. Mold constant Cm is the time for solidification by volume divided by A area raised to N. So we need to find the volume of rectangular plate. Here we have the volume given in the question. We get the volume. We get the surface area by multiplying. For example, if this is one side, this width times thickness. So we have two ends. This is one end, and we have another end here. Hence, 2 times 7.5 times 12.5 plus 7.5 times 2, etc. to calculate the total surface area. So 2 ends in here, 2 ends on the opposite sides. Hence, we have 6 surfaces. We get the total surface area, and the n is already 2. Using this, we calculate the mold constant Cm of the casting. Mold constant is same for the casting as well as for the riser. So we get the mold constant using the Chevronn's equation. Solidification time for the casting is 1.6 minutes, and volume is volume we calculated, area we calculated, and n is equal to 2. We get Cm mold constant is equal to 3.26 minutes per centimeter square. So then, using this mold constant, we have got the mold constant of the casting. It will be same as the mold constant for constant for the riser. So now we have to design a riser which is having a cylindrical shape. R is the radius, h is the height. We know volume of a cylinder is pi over 4 d square, diameter square times h, the height. Surface area, the surface area is pi dh plus 2 pi over 4 d square. Pi dh is the circumferential area. You can see here circumferential area is pi dh plus the area at the 2 ends. Area at one end is pi over circumferential area is pi dh, this area pi dh, and then area at the end you can see here pi over 4 d square h, and there are 2 areas, hence 2 pi over 4 d square. 2 pi over 4 d square. So we have 2 areas in here. One is the circumferential, as I told before, pi dh, this peripheral or circumferential area, and the second is area at one end here and area at the other end. Area at this end is pi over 4 d square. Area of the other end is pi over 4 d square. So it is 2 pi over 4 d square. Using this, we get the total area, and then we find in the question itself, it is given diameter to height ratio is 1, so diameter is equal to height. So substitute here, instead of h, you can substitute d. So we get pi over 4 d cube. Here pi d square plus 2 pi d square over 4. So this is a volume and area. When we take the ratio volume divided by area, we get we can cancel d cube and d square, we get d over 6. So we take the ratio v divided by a. V is pi d cube over 4 and a is 1.5 pi d square. When we take the ratio, we get d over 6, the area. Now we already calculated Cm from here, mold constant from the casting, which is 3.26, which will be the same mold constant to be used for riser as well. So the equation is total time, solidification time is given for the riser, which is 2 minutes, is equal to Cm, the mold constant, which is constant for the casting as well, is 3.26 times V over A, which is D over 6 raised to 2 is a constant. From this, we get the diameter is equal to 4.7 centimeter, and height is also same because in the question it is given that height and diameters are same. Now we have designed a riser, and in order to get a casting of this shape, we need to have a riser which has a height of 4.7 centimeter and diameter of 4.7. If we produce a riser with a diameter 4.7 and a height 4.7, then we will get a particular casting of as per the question, which is a rectangular plate. Now, if you analyze it closely, you can understand that the volume of the riser is 81.5 centimeter cube, whereas volume of the casting is around 187.5. That means only 44% of volume of casting is required in the case of a riser. Even if it is very less in volume, if you compare with the volume, the volume of the riser is much less than the volume of the casting, but it takes long time to solidify. This is the factor you should understand in here. Even the volume of the riser is much lower than the volume of the casting required. The time required for solidification of the riser is much more than the time required for the solidification of the casting. This is very important in the case of a casting. Unless metal will get choked and metal will freeze, metal will not flow, will not get a particular shape. These are the important factors in a casting process. Now, I'll give you an activity. Take a tour of how everyday things are made. For example, cars, how cars are made, how motorbikes are made, how airplanes are made. These are transportation systems. Then we have packing, how glass bottles, plastic bottles, food containers are made, candy, chocolate, how candy. Just think over it and just see how these products are made. I can give you an example. I can give you an example of cars. You have to search and find how motorbikes, how airplanes are made, how glass bottles are made, how plastic bottles are. Just take a tour of how everyday products are made. I can give you an example of car. How car is made. Basically, car consists of body, then engine gearbox part. First part is the car body, then chassis, and then engine gearbox, then other accessories inside the car. We need to assemble all these to produce a car, right? So let us start with how we produce car body. Look at that. Car body is produced by a manufacturing operation called stamping operation. After stamping operation, we produce the shape of the body, and after welding, we join them together, and after painting. So after welding them, after welding the body parts, we get a complete body part. After painting, we get the final appearance of the body.